Hey there, want to look at something from section 8.3, which is end behavior and other features of polynomials. So what we're looking at here is the idea of being able to give you guys a function, an equation, a polynomial, and have you guys tell us some things about the graph. And these two polynomials here are the same, one's just in general form and the other one's in factored form. And they do just tell us slightly different things. Easiest thing to know about a polynomial is, and when it's in general form, is its y-intercept. And so you see that the y-intercept of this is going to be 3. Another thing we want to be able to talk to us about when you're looking at in general form is what's called the end behavior. And it really is what it says, basically asking us, like, what are the ends of the graph doing? So what's, as the graph heads off to the left, how is that left arrow acting? Is that left arrow going up or is the left arrow going down? Like, which way is that end going? And the same thing as the graph goes off to the right, is the right side going up? Is the right side going down? It's kind of what we're looking at here. And so I'm going to bring in the graph here for this one. Normally we don't want to have to look at the graph for this, but I want to just do that real quick. And so we can see this, as we look at the graph, the left end is going down and the right end is going up. And so that's how I would describe the end behavior of this. And on your homework, you guys have like a little script that you're going to use. And it just goes, as the x goes left, y goes, sorry, my handwriting here, oh Lord, y goes, and then there's blank. And then so what's that left end doing? That left end is going down. And then as the x goes right, y goes, in this case, up. So the idea here is to be able to do this without looking at the graph. And so how we do that is by looking at two things about the polynomial. One of them is the degree, and the other one is the leading coefficient. And so the degree is the first thing you want to look at. So and what we want to know about the degree is whether it's even or odd. And so 3 is odd. And whenever we look at something with an odd degree, like a polynomial with an odd degree, the left end is going to act just like this one did. The left end is going to go down, and then whatever's going to happen in the middle, we don't know. Like, it depends on what the degree is. All these little deciduals in the middle. And then the right end is going to go up. So whenever the degree is odd, the left end will go down, the right end will go up, so they go in different directions. And so it's kind of nice, like odd, different. But if you remember that odd goes with an n, so just that left end's pointing down and the right end's pointing up. Again, whatever happens in the middle doesn't really matter, whether it's like this. You can do all sorts of things, but what we care about is that the left end is going to go down, the right end is going to go up when the degree is odd. Oops. And so odd is an n, and then since it's positive and odd, the right end should go up. So if I know the right end goes up, then the left end would go down. Now, if the leading coefficient had been negative, we would just take our n and we would flip it. And so now the left end is going to point up, and the right end would then point down. But I would just recommend that you know the positive version, that an odd is an n, and then looking at this later, if you want to just flip this in the moment, you don't need to remember that it's an upside down n. You just know that negative here would be a flipping this. And then you would see it. So if odd is an n, then if the degree is even, what we end up with is like a u or a w. So we get the left end points up, and then the right end, inside the middle does all blah, 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 dipsy doodles, and then the right end would also point up. So odd, the ends go in different directions, odd, different, makes sense. And then if that number had been even, the ends go in the same direction, even, same, like those words kind of go together. So, but odd goes with an N, and then if it had been even, if the highest exponent had been even, we were looking like a W or a U, where both ends go up. And the same thing with, since it's positive, the right end should go up. And then if it had been negative, we would just take our W and we'd flip it. And okay, both ends go down. So I would say, as x goes left, y would go down. As x goes right, y would go up. So that's how I would describe that. But I want to do that without the graph, right? So there's the idea. So we're going to use those letters to help us. So that's the main two things coming from the general form is the end behavior and then the y-intercept. From the factored form, we see the x-intercepts. So here that one of the x-intercepts is at 3, 0. Another one is at 1, 0. And another one is at negative 2, 0. Right? So that we can see that here that 3, 0 is here, and 1, 0 is here, and then negative 2, 0 is here. Right? Gotta watch those signs. We can also see the y-intercept here. It just takes a little bit of work. Or if we take all of the numbers in here, signs included, you multiply them. So 0.5 times negative 3 times negative 1 times 2. Multiply 3 times 1 times 2 is 6, and 2 negatives is a positive. So I have 0.5 times 6, which of course is 3, which is what we said before, right? Oops. So you can see that you can kind of see the y-intercept. You just have to do a little bit of work, but it's not a lot of work. So there is the y-intercept when you multiply all of those numbers. Not these numbers, and these numbers over here. You can see that y-intercept at 3. All right, let's try another one. It's a new function here. We'll do this one without graphing it first. Then we'll use our graph to check it. So again, the easiest thing to look at is that y-intercept. Oops. So should be able to tell the y-intercept from the general form very quickly. The y-intercept is 12. And then I want to look at the end behavior. So for the end behavior, I want to look at that degree. And I also want to look at the leading coefficient. So the degree is 4, which is even, which means I should be thinking about a W or U. And then the leading coefficient is negative, which means I'm going to take that and I'm going to flip it upside down. So instead of a W, I'm going to think about an upside down W, aka an M. And that's what I'm going to use to help me write my sentence. So I want to describe that left end first. So as x goes left, what's y doing, right? So what's the y doing? Y is going down. Good Lord, handwriting, rough. And as x goes right, so what's the right end doing? Y is also going down on this one. So what are the ends doing? All right, so we think, and then what are my x-intercepts? So here I'm going to have one at 1. I don't want to write that. 1, 0. This one's going to be the same one, so 1, 0. Something we talk about in section 4, like when it happens we have two x-intercepts at the same point. This one's going to be 2, and then this one will be at negative 3. So I should have 3 x-intercepts because 2 of them are the same. Both ends should point down, and the y-intercept should be 12. So let's look at our graph and see if we were right. So see the y-intercept is 12. the left end is going down, the right end is going down, and then x-intercept at -3, an x-intercept at 1, and an x-intercept at 2, which is exactly what we said. So go us. All right, so that's end behavior. Remember the two letters. Odd is an N, and then even is a W or a U. And then if the leading coefficient is negative, then you just take those letters and you flip them upside down and just kind of sketch that out to help you remember how to talk about the end behavior. I really would suggest using those letters, those little sketches. Do that as you're working on that. And hopefully the rest is easy enough. Take care.